Hello and welcome to the second half of the 1.1 exercises solution set. If you already watched part 1, you know that we've been using the calculator a lot for these. We're going to continue to do that in some of these problems and show you how to use some cool things on your calculator. So let's start with number 26. It says to write an exponential notation and evaluate. So let's focus first on writing and then we'll plug them in the calculator. So in number 26, there are 1, 2, 3, 4 7s being multiplied by each other. So 7 is our base, and then we're going to write a 4 as our exponent. So let's go now to the calculator. So it's part of our answer. Then we need to evaluate it, which means get the number itself. So we're going to type a 7. Now on this calculator, I have this little x to the y power button. Yours might look different. It might be, I'll write it over here, something like a to the b. It might be x to the box, like a blank square right there. I've also seen very common a caret, so an upside down like v. So you'll type first the base, and then you'll push your exponent button, whatever it looks like. So on my calculator, I'm going to push x to the y. And see, it says a little caret up there in my calculator. So I'm going to push 4 and equals. So my answer for number 26 is 7 to the 4th power, which is 2,401. You can also type in your calculator 7 times 7 times 7 times 7. Like that gets a little long, especially on a number like 28. So on number 27, let's keep going. We have negative a as our base. So in order to show that the negative is attached to the 8 the whole time, I'm going to put it in parentheses. And then I'm going to raise it to the 3rd power because there are 3 there. And let's look at how to put that in the calculator. So you notice on my calculator I do have parentheses, so I'm going to go ahead and type that. And I have my 8 with its negative, and close my parentheses. That way, again, the negative stays with the 8. Sometimes calculators misinterpret how you type a negative, so I keep it in parentheses. And then I'm going to put my exponent button again, and raise it to the 3rd power, and I get negative 512. Notice, because there are 3 negatives, we should end up with a negative answer. Whenever you have an odd number of negatives, you get a negative answer when you're multiplying. Alright, number 28 is the big one. Let's go ahead and count the 2's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 2's, so 2 is our base. So our exponent notation is 2 to the 11th power. Let's type that in the calculator. 2048. 2048. Okay. 29 and 30 both have a tricky thing because you notice that the negatives do not stay with the base the whole time. So what I'm going to do is I'm just going to detach it from the base. So I'm not using parentheses this time. And I'm just going to write the 11. There are 1, 2, 3, 4 11s. Okay. So when I go to type this one in the calculator, I'm going to type 11, and I'm just going to ignore the negative for now. I can type it in different ways, but I'm just going to ignore the negative, get my answer, and then I'm going to have the negative attached to it. So pretty much just ignore it and keep it in the front the whole time. That works. Number 30, I'm going to do the same thing, ignore the negative, it's just going to hang out front. 1, 2, 3, 4 5s. So that's 5 to the 4th power. Let's type it in the calculator. 5 to the 4th power is 625. Go ahead and tag that negative back on. Negative 625 for those answers. Alright, 31 through 34 is another one where it's just type in the calculator. Of course, you might already know number 31 or some of these other ones. But let's type in the calculator just to show you how to do it. So I'm going to type the 36 first, and then my square root. In your calculator, it just depends. It might be type the square root first and then type what's under it. Either way, you should get 6. So whole number of 6. Let's do one more, and then I'll let you check the rest on your homework. So we're going to type 30.25. Push the square root button, and that one is 5.5. Again, the other two you can check on your answers page in the book. Let's look at 35 through 38. Now we're switching into scientific notation, and we want to convert it into decimal notation. Any of these that have a positive exponent mean that they're big numbers, so bigger than 0. Anything, or not 0, bigger than 1. Anything with a negative exponent means it's really small, a fraction number less than 1. So on 35, because I know it's going to be a big number, I'm going to write it to the left so I have plenty of room for my zeros. So I have 5.30, and I'm just going to move the decimal 9 times, because every time you multiply by a 10, it moves your decimal. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're going to have lots of zeros. On this one, just fill it in with zeros. So, and every time we have 3, we're going to have a comma. So that's 1,000, a million, billion. So 5,300,000,000 on number 35. 36, again, we're going to have big numbers, so I'm going to write this to the left, so I have plenty of space for my zeros. I have 1, 2, 3 already, 4, 5, 6, 7. So fill those in. Put my commas, so 80,150,000. No. Alright, remember 37 and 38 are going to be small numbers. I'm going to write them to the right, so I have room for my zeros. And I'm going to move once, 2, 3, 4, 5, going left this time because it's making the number smaller. It's like I'm dividing by tens. 0.0000954. 38. Again, oh, I might not have enough room. We'll try it. We'll do it up here. 3.14, because there's a lot of zeros in this one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I also wrote them kind of big, so let's fill those in. Very small number. 0. I'm not going to read them all until you get to 314. There you go. And numbers 39 through 42, we're going to go the other way. So we're going to start where the decimal is and count. 1, 3, 4, 5, 6. And we want to stop when we get to a number where it's just one number in front of the decimal point, and that number is not 0. So 2 is bigger than 0, so we're going to stop there, and it's going to be times 10, however many zeros we counted. So that was 6. 1, 2, 3, 4, 5, 6. And because it's a large number, it's going to be positive. And we'll go to the next one. We're going to move our decimal place 1, 2, 3 times. So that's 4.3. Stop when we have one number in front of the decimal that isn't 0. 10 to the third. 1, 2, 3. Positive number because it's large. Now on 41, 42, or no, just a 41, is a small number, so it means we're going to have a negative exponent, and we're going to count the other way. 3, 4, 5. We're going to stop at 8.2 times 10 to the negative fifth. And the idea with these ones is if we were to change them back, like we did on 35 through 38, we'd start back at the same number. Alright, so this one's going to be big. It's going to be positive 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 5.28. Don't have to write the zeros. Times 10 to the positive 9th. There we go. Okay, we're going to do the rest in the next video.